Hey everybody, I thought I'd take a moment to go ahead and walk through some of the problems together so that you have a reference point to be able to understand and make sense of these type of work. So what you're looking at on the screen right now is problem number one, which is essentially asking how do we go ahead and find the total resistance on series and parallel circuits. And so in order to find the total resistance on series circuits, it's really quite easy. And so the equation that we use to look for that is R total, yeah, is equal to each of the resistors added up directly. So I would say R1 plus R2 in this category, right? Where I have these two resistors where I could maybe call this one R1 and I could call this one R2. So I could add those up straight, which makes it nice. I don't really have to do a lot of work here. It's 30 ohms plus 20 ohms, right? And the entire answer to that is 50 ohms. Now, I'd like you to take note that I wrote more than just 50 ohms. I could have just written 50 ohms on there because honestly, I can look at it and say 30 plus 20 is 50. But I wrote a few things. Number one is that I wrote my starting equation for this. So I wrote my R total equals R1 plus R2. So I have an equation. And then I wrote in the things that I plugged into that. And then I wrote my final answer. Now, the reason I did all of that is so that I can get back to this information and be able to know kind of where I got this. Showing your work is not only for you, though. Of course, it's partly for you. It's also for communication to other people that you know what you're doing. And as you work forward in the world of science and or the world of business or whatever that job might be, clear communication is what we're looking for. So I wrote it all out, and there's an expectation that you would too. Often we like to cut corners, and it's time to stop cutting corners and to write it out so that we have clear communication. So for the second one, same idea, R total, only this time around, we've got this three resistors. So R2 and R3, right, that we're adding on to it. And those three resistors, we could maybe call this R1, we can call this R2, and we could call this R3 going around the circle. And to add those things up, I'm going to do the same as I did before. So I've got 10 ohms plus 15 ohms plus 70 ohms. Once again, writing it all out so I've got clear communication of what I'm doing. 10 plus 15 is 25 plus 70 gives me 95. And my units on this one are ohms. So pretty easy. When it comes to things being in series, it's pretty simple. When things being in parallel, things change a little bit, right? And we end up with everything being kind of upside down or inverted. And so we would say that 1 over the total is equal to 1 over the first resistor plus 1 over the second resistor. And that does a few things. One is it complicates the right side when you're trying to add things together. And two, when you're finally solving for the total, we end up having to flip everything over in the end. And you might say, well, isn't it the same? Can't I just flip it? Well, no, you can't, because we have to find our common denominator and add things together. So we can't just flip everything and have it be back to normal. So the way that I would solve this, right, is 1 over R total is equal to 1 over 10 ohms plus 1 over 20 ohms, right? And I might look at this and say, well, let's find a common denominator because it's easy to do. And that common denominator, right, is 20 ohms, which means that I have to change this fraction to have it work out for me. So again, 1 over R total is now equal to 2 over 20 ohms plus 1 over 20 ohms, right? And if I add across the top, I'm going to move this down a little bit so I have a little more room. If I add across the top, we end up with 3. And then the bottom keeps the common denominator of 20 ohms on the bottom. And this is still 1 over R total, right? So my final response to this is that I need to go ahead and flip what I've got. So I'm going to flip this side, and now I can flip this one because I'm not adding different pieces together, which finally gives me an R total is equal to 20 ohms divided by 3. So 20 ohms divided by 3. You could do that by hand, or you could use a calculator to do so. So 20 divided by 3 gives me this number, right, of 6.67. And then the amount is in ohms. So our total is equal to 6.67 ohms, which is less than any one of the two resistors up at the top. So if you look at the two resistors up at the top, you'll notice that 6.67 is less than 10 and 20. And that's important. So I'm going to do this a little bit more quickly on this next problem, but you get the right idea, and maybe a little bit smaller, so it's not quite so spread out. So 1 over r total, I'm just going to use a t for this, is equal to 1 over r1 plus 1 over r2 plus 1 over r3. Right? And I'll do that again. So that's 1 over 10 ohms plus 1 over 20 ohms plus 1 over 30 ohms. And if I'm looking for my common denominator for this one, I've got 10, 20, and 30. 20 doesn't go into 30, but if I double 30, I get 60. So 10 does go into 60, 20 goes into 60, 30 goes into 60. So I think 60 ohms is what needs to go on the bottom of this. So in order to make that happen, I've got 1 over r total. And if I need to get this to 60 ohms, then I need to multiply by 6. So I've got 6 over 60 ohms plus, and if I need to get 20 to 60, I need to multiply by 3. So I've got 3 over 20 ohms. And then the last one, I need to multiply by 2. So 2 over, excuse me, throwing it at 20 in there. That's 60 there, isn't it? 60 ohms, and this is over 60 ohms as well. There we go. That looks much better. All right, so I add across the top and keep the bottom as it is. So the 1 over r total is equal to 6 plus 3 is 9, plus 2 is 11, divided by 60 ohms. Right, we're almost there. Last but not least, I'm going to go and flip this side, and that means I can flip this side as well. So what I'm left with here is that my total resistance is equal to 60 over 11 ohms. And I could leave it there, but often we go ahead and put things in decimal form. And so I've got 60 divided by 11. And my total resistance here, RT, is equal to 5.45 ohms. Repeating, so this is my final answer as a whole. So I've got it. That is a lot more work, right, than just what I did for the ones in series. So finding the resistance in series is a lot easier than finding the resistance in parallel, right? Not so bad. Hopefully that was helpful to you, and I'll see you in the next one. All right, take care, everyone. Bye-bye.